we're going to look at the concept of electricity, and this topic is meant for KS3 according to United Kingdom National Curriculum on Physics or General Science, so to say. So the key point we're going to look at here is electricity is the presence or flow of charged particles. Our students need to understand this. This is very, very important, that electricity is the flow of charged particles, okay, or the presence of charged particles. I'm still trying to get that done. All right. So once you hear electricity, what should come to your mind is these constitute the presence or flow of charged particles. That's it. So anything. Then electric current. Electric current is different from electricity. It's a different thing altogether. An electric current is the flow of electrons around a circuit. You must take note of that it is the flow of electrons. And electrons are what? Charged particles. Negatively charged particles. But this time around, they are flowing, or rather passing around a circuit. A circuit, in my previous video, I defined a circuit as an electronic or electrical path designed for the free passage of electric current. Then we have what we call static electricity. It's the build-up of electrons on an insulator. I repeat, static electricity is the build-up of electrons in an insulator. So that's what that should be. And the other one is small facts that you need to know. Did you know that electricity travels at the speed of light, about 3,000 kilometers per second, meaning in every second it travels 3,000 kilometers. What's an astronomical distance? Did you know that electricity was first discovered in 600 BC, before Christ? That's mean of BC. Ancient Greeks discovered static electricity. Did you also know that electric cars were first used in 1832? Yes, you heard me right. 1832. Electric cars. What we are trying to see as if it is just happening now. No, it has been a long time. Okay? Alright, so let's look at that. Let's take note of that. It's very, very important. So the next thing we are going to consider here is illustration of the presence of charged particles between two conductors. When you bring two conductors and try to brace them against each other, you see this kind of particles, live wires, brace them against, okay, or rather scratch them against themselves. You will see this kind of built particles giving blue lights, a sea, a cloud of charged particles. The same thing is similar when there is a thunderclap, when there is a strike, thunder strike. You see the electrons split, accompanied with a heavy noise, and you see blue lights. That's what it means, meaning because there is a charged particle somewhere. Alright, so let's look at how is electricity used. Everything is made up of tiny particles. Of course, these tiny particles may have positive or negative charges. Electricity is the presence of flow. Is the presence or flow of charge of these charged particles. We must take note of that electricity is the presence or flow of these charged particles. All materials. Another thing we must understand is that all materials contain negatively charged particles called electrons, no matter whatever the materials are. In metals, for instance, the electrons are free to move, which means they are good conductors of electricity as well as conductors of heat. Of course, metals that conduct electricity can also conduct heat. So good conductors of electricity are also good conductors of heat. That's said. Then the third one is if there is a complete circuit. Yes, if there is a complete circuit. Wow, very, very interesting. A battery can push electrons around the circuit. And in the process of pushing electron around the circuit, current is produced. I repeat, if there is a complete circuit, a battery can push electrons around the circuit, and in the process of pushing electron around the circuit, current is produced because electrons also are charged particles and they are negatively charged. This is an electric current. Good. Well explained. Look at it. It's an electric current. Here, we use electric currents to control and operate devices including phones, computers, and light bulbs. So take note, functions, applications where this small amount of current can be applied. Okay, so let's look at the next one. How is electricity used? We continue with that. Some materials do not conduct electricity. Yes. When current passes through them, they don't conduct.